Hey everybody, this is Mr. Paracone, and this geometry lesson is on midsegments and a little bit of coordinate proof. Alright, let's go ahead and begin. So some definitions. A midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. Every triangle has three midsegments. Okay, so for example, you guys, here's triangle ABC right here. Can you see that this is the midpoint right here because of the markings right there? P is the midpoint, N is the midpoint because these three dashes and these three dashes, and M is a midpoint because these two dashes and these two dashes. So MP is called a midsegment, MN is called a midsegment, and then finally NP. These are all midsegments because they're joining the midpoints of the triangle. Okay, midsegment theorem says this: a midsegment of a triangle is parallel to the third side, always parallel to the third side, and it's always half as long. Alright, so here's a midsegment because these guys are midpoints right here because of the markings, and these are midpoints over here. That's the midpoint right there, and these are DE is joining the midpoints. So these arrows mean that it's parallel because the midsegment's parallel, and this is half the length of this. I like to say this: AC is twice the length of DE. I think it's easier so I don't have to deal with the fractions. Okay, so find the value of x in each figure. Here we go. Okay, it looks like I have a midsegment there. So x plus 14 is half of 3x plus 12, or better yet, 3x plus 12 equals twice x plus 14. Okay, so when you solve for x, you get x equals 16. All right, try this one here. I'm going to do the same thing. This bottom piece is twice this midsegment right here, so x squared minus 6x plus 3 equals 2 times the quantity 3x minus 16. All right, distribute the 2 through. Okay, now this is a quadratic, so I want to make it equal to 0, so I'm going to subtract 6x and add 32 to both sides. So I'm going to subtract 6x there and add 32 there. Careful, you guys. Negative 6x minus 6x is a minus 12x, you guys. It's not 0. Okay, all right, and then factors of 35 that add to negative 12 are negative 7 times negative 5. So by the zero product property, x minus 7 equals 0 gets me x equals 7, and similarly I get x equals 5, and then just kind of go check, you guys. One of these answers doesn't work. I'll show you 5 doesn't work, because if I plugged in 5 right there, 3 times 5 is 15. 15 minus 16 is a negative number. I can't have a negative length right there, so 5 doesn't work, only 7 does, you guys. Okay, so triangle OCM is the midsegment triangle of triangle APD. So what's the perimeter of triangle OCM? Okay, well these are all midsegments right here. So if this is 3 right there, let's see, it says what's the perimeter of triangle OCM? Okay, all right, so this side right here is twice this midsegment right here. So this midsegment is half 9, so this is going to be 4.5. And similarly, if that's 4, because of the markings, 2 dashes, 2 dashes, this is 4 right there, so this whole thing is 8, so this midsegment is half of that, so this is 4. So 4, this was 4.5, and that's 3, so the perimeter is going to be the addition of all those, and I get 11.5. Okay, so place each figure in a coordinate plane in a way that's convenient for finding side lengths, and assign coordinates to each vertex. So this is really vague, you guys, and I actually had to look in the book to see what the heck they were talking about. They just want you to draw a rectangle in this coordinate plane right here and draw a scalene triangle in this coordinate plane. Well, what I did is I used this origin as my right angle right there for both the rectangle and the scalene triangle right there. Okay, and it said just locate their name the vertices. So you know, this is a 5 by 2 rectangle. You could have made a 3 by 4 rectangle or a 1 by 7 rectangle. It didn't give you any qualifications on that. So same with the scalene triangle. I made it a 3, 4, 5 right triangle. This is 3, this is 4, this is 5 right here, and that would be a right angle right there. So there's a scalene triangle right there. Alrighty, that's it.